So see now next numerical is KCET problems on potential due to the system of charges. Okay. So see first question. Figure shows the electric field lines for a positive charge. The work done by the field in moving a small positive charge from Q to P is. Okay. So what they are saying here, they have given the electric field lines for the positive charge, and they are asking what is the work done by the field in moving a small positive charge from Q to P. Okay. So keep it in mind for the positive charge. So the electric field line starts from the charge and ends at the infinity. Okay. For the similarly for the isolated negative charge, it will start from the infinity and ends at the charge. Okay. And another concept is if you do the work against the electric field, so it can be taken as positive. Okay. So if you do the work against the electric field, it is positive, and if you do the work along the direction of electric field, it is negative. Okay. And if you do the work, so work done by the external agency is negative. Okay, work done by the external agency is negative. I told 3 points now. Work done by the electric field against the direction of electric field is positive. Work done by the electric field along the direction of electric field is negative, and work done by the external agency is negative. Okay. So here what they are saying, so the work done by the field in moving a small positive charge from Q to P. Okay. So here electric field is also is going on this side, and we are doing the work done from Q to P also here along. So along means we will get as negative. Okay. So this is the required solution. So now next numerical, 27 drops of same size are charged at 220 volt each. They combine to form a bigger drop. Calculate the potential of bigger drop. Okay. So here what they are saying, here they have given 27 drops. Okay. So 27 drops of same size are charged at 220 volt. They will charge that small charge, and it will become bigger sphere. Okay. Bigger drop or bigger sphere. So calculate the potential. We need to calculate the potential of bigger drop. Okay. So what the data they have given? So n value they have given, n is equal to 27. Okay. And charged means, so so that is 220 volt. Okay. So each they combine to form a bigger drop. Calculate the potential of bigger drop. So potential of bigger drop, it is equal to question mark. Okay. So this is the values for the small drop, and we need to calculate the values of the bigger drop. Okay. See here, so here charge becomes, so 27 times of Q. Okay. So the charge of the bigger drop becomes 27 times of the charge. Why? Because all the charges are combined together to form a bigger drop. Okay. And here, so I will take, let R is the R is the radius of the bigger drop, and small r is the radius of the smaller drop. Okay. So here, so it can be taken as the sphere. So here volume of the sphere is 4 by 3 pi r cube. Okay. So that is equal to how many times? So here they are saying 27 times of smaller drops. 27 smaller drop means 4 by 3 pi r cube. Okay. So from here I need to find out the relation between capital R and small r. So here it will become 4 by 3 pi cancel, 4 by 3 pi cancel. So here r cube is equal to 27 times small r cube. So r becomes, here it can be written as 3 times 3 r cube. So r becomes 3r. Okay. So this is the relation. So r is equal to, capital R is equal to 3 times small r. Okay. Now see now, so this can be taken as a sphere. So here capacity of the charge spherical shell. Capacity of the charge spherical shell is given by the formula C is equal to 4 pi epsilon naught r. Okay. So this is one relation, and we need to calculate the, ultimately we need to calculate the potential. Okay. So we know that C is equal to Q divided by V. Okay. Capacitance of the capacitor formula, C is equal to Q by V. Here we need to calculate the V. So now V becomes Q divided by C. Okay. So here Q we have taken as Q dash, right? So that is equal to, what is Q dash formula? Q dash values 27 times of Q. So divided by C. So what is C? So 4 pi epsilon naught r. Okay. So that is equal to 27 times Q divided by 4 pi epsilon naught. What is r? R value is 3r. Okay. So here simplify this one. So 3 ones are, so 3 9s are 27, right? So 9 into 1 by 4 pi epsilon naught q by r. Okay. So here see here 1 by 4 pi epsilon naught q by r can be written as v. Okay. So that is equal to 9 into, what is v value they have given? 220. Okay. So 9 into 220 means approximately will get 1980 volt. Okay. So this is the required solution. So see now, next numerical is 4 charges minus q and minus q plus q and the plus q are placed at the corners of the square of the side 2L is shown in the figure. So the electric potential at the point A midway between the two charges is. Okay. So here they have given the 4 charges minus q and the minus q plus q and the plus q and having the side 2L. So we need to calculate the potential at the A midway between the 2 points. Okay. So here I will draw the diagonal here. Okay. So due to the plus 2 plus q charges, I need to calculate the midway, and due to the minus q and minus q, I need to calculate the midway. Okay. So here, so the total length is L means, so one side becomes L. Okay. So this is also L, this is also L, and total length is 2L. Okay. So this length we know. So what is R value? L here. Okay. So another R value, this value we need to calculate. Okay. So this is right angle triangle. So apply Pythagoras theorem. So square of the hypotenuse is equal to base square plus perpendiculars. I will take it as R square, and what is base value? So total is 2L. So 2L square plus perpendicular is L square. Okay. So it will become 4L square plus L square, that is 5L square, and R becomes root 5L. Okay. So this is the R value. Now we need to calculate the potential at A. So potential at A means VA is equal to, what is potential formula? VA is equal to 1 by 4 pi epsilon naught q by r. Okay. So 1 by 4 pi epsilon naught, I will take it as K. So here we have, due to the plus 2 plus q and plus q, we have 2 times. So 2 times of potential. So 2 times K q divided by r. R value we have L. Okay. So similarly, so due to the minus q2 charges, so I have 2 times of K minus q divided by, so this, due to the minus q charge, what is this length? So this is 5L. So this is also 5L. Okay. So this one is root 5 times of L. Okay. Now from these two terms, so what is common here? 2K q by L is common. Okay. So here 2K q divided by L is common, and remaining is 1 plus into minus 1 minus 1 divided by root 5. Okay. So this is the required solution, 1 minus 1 divided by root 5. Okay. So 1 2 q k 1 by 4 pi epsilon naught L. So this is the required solution. Okay. Now see, now next numerical is 3 charges 2q minus q and minus q are lie at the vertices of the triangle. So the value of E and V at the center of the triangle. Okay. So here, so they have given a triangle. Okay. And they are placing the 3 charges at the 3 vertices. Okay. So this is one vertices, this is one other vertices, and another one is this one. So here minus q charge and minus q charge and 2q charge, they are placed at the 3 vertices of the triangle. So here I need to calculate what is the value of E and as well as V at the centroid of the triangle. Okay. So now I will calculate the V. Okay. So V, due to the minus q charge is, so 1 by 4 pi epsilon naught minus q divided by r. Okay. So similarly another charges 1 by 4 plus 1 by 4 pi epsilon naught minus q divided by r. Okay. So due to this one, plus 1 by 4 pi epsilon naught 2q divided by r. Okay. So see here, so I have taken minus q charge and plus 2q charge. Okay. So that is equal to here, so how many terms are there? 2 terms are same value only. Okay. So that is minus 2 times of kq divided by r plus K times 2Q divided by R. Okay, so here plus and minus get cancelled and V becomes 0. Okay, so potential value is we are getting the 0. But what is the value of electric field? See, due to the plus Q charge, we will get one electric field like this one. Okay, so due to the plus Q charge, we will get one electric field, this one, towards, not towards, away. Due to the negative charge, so we will get electric field towards, and due to the negative charge, and we will get a one electric field towards. Okay, so that's why E is not equal to 0. Okay, so option is V is equal to 0, but E is not equal to 0. Okay, so which is the option here? So V is equal to 0 and E not equal to 0. Okay, so this is the required solution.